Can you hear me?
I think
No? Oh, now I can. Okay. Hi, everybody. So I think we are going to have to share the mic here, so it's going to be a little intimate. So I see that the clouds outside have turned into rain. So that's why everybody is sitting inside. So we are lucky to have your participation. Thank you very much. So we hope to really entertain you. So I hope the panelists have prepared a lot of very entertaining anecdotes and jokes. Mentions about Trump are okay. Yeah, but it should be about election analytics, micro-targeting, so that would be great. So the panel is about cloud and big data. I'm not going to bore the heck out of everybody with my perspectives because I think we are really here to hear from this August panel here. So without much ado, so what I would like to do is to just go around the panel, just have the people introduce themselves a little bit and give their perspective on cloud and big data. And then we will, since we have only really total of 30 minutes, so we don't have much time to dive deep into the topics that we want to. So I would like to request the panelists to keep the initial remarks really brief. And then we will get into the topics that we have discussed before and hopefully bring a lot of insight to the audience here. And we do hope to reserve a few minutes at the end for questions. The mics are set up. So, please feel free to be controversial. We'd like to have some fun, to have you guys fighting each other. So, and stoke up the audience so that they'll come and ask us even more provocative questions. So I'll try to maintain order. No chair throwing, please. So without much ado, I'll hand it over to Amit here.
Okay.
Please.
All right, we are in sharing mode today. So given that we can be controversial, we'll build walls around the cloud. We'll make the clouds be great again. If we have to be.
How tall is it going to be?
We'll see. We'll see if we are in Trumponian mode now that he's the presumptive nominee. Well, good afternoon, everyone. My name is Amit Walia. I run all products for Informatica. In some ways, that's what we do. It's a data company, all about data. And again, so it's $1 billion company. We've been around for 25 years, so across all the avenues of data. And I think coming to the topic versus spending time on the company that I work for, I think clearly this is one of the cloud, big data. I mean, these are the two fundamental changes that are happening in the realm of data. One is obviously the size of data is increasing. Needless to say, the processing is changing because cloud is in some ways not only a generator of data, but it's also a place where data processing is going in some ways, right? And I think if you flip it in the last biggest trend, I think it's allowing, in my mind, the true new enterprises to derive what I call value-generated insights or analytics to make decisions. At the end of the day, that's what it is all about. Make better decisions that deliver you value, which in the old world obviously took a lot more time. And in the new world where competitive advantages, obviously it's all about how you can better respond in a millisecond or a microsecond. To me, that's what it allows in a nutshell. So clearly it's a very disruptive area, and obviously we'll discuss more of that in the coming few minutes.
Thank you.
Thank you. So it was great to hear, Amit talk about all this, clouds and how high we're going to build and things. I think we need to really talk about how wide we're going to build because it's a data problem and it's data gravity problem. And to put some context, I've been in the data business for probably now 12 years. I started out with a startup called Gemstone, which was initially building some in-memory data management products and in-memory data grid, which got acquired by VMware. So I'm right now at VMware, which pretty much laid out the ground for the private cloud revolution. Within VMware, I continued to enhance and integrate this product into the big data. And there was a data initiative which got spun out into a Pivotal. So when I moved into Pivotal, we worked on what are the two aspects of data. One is the big data, the batch mode, and the other side is the what is called the low latency, high performance, fast data, or bringing those two together really, because you can run all the analytics on big data, But if you can't respond in the millisecond time frame, then the data is not that useful. So that's what we spent quite a bit of time building and do. I think one of the key things is the technologies that we initiated there actually eventually had been open sourced. So there is a Apache Geode project, which actually is the open source version of the what I call the data aspects that we built. And on top of that, in fact, 2 new startups have been started based on that. So this aspect of data and analytics is the hardest thing. If you guys have heard about Spark and Spark streaming, that's all relevant. And that's where I think the key aspect of cloud and big data is going to collide.
Okay. Hi, I'm Debanjan Saha. I run Amazon Aurora. This is one of the relational database service which is part of our big data portfolio. I started as a networking engineer in IBM Labs, then did an optical networking startup, then I ran storage development for some time, and now doing databases. So it's kind of I moved data, I stored data, and now I'm analyzing data. So one thing I wanted to mention, just adding to what other panelists just said, one of my focus is to see how can we make big data very easy for customers to adopt. And one way to do that is to make the experimentation with big data really, really easy, right? So you can set things up very quickly, you can tear them down very quickly. There is no risk of setting up an infrastructure if you can, tear it down very quickly. I'll give one quick example. I mean, if you, for example, use AWS and you try to process, let's say, the entire Twitter fire hose, right? 500 million to probably 1 billion tweets every day. You can get that through Kinesis, then you can store it in S3, then you can analyze using Redshift or EMR. And the whole pipeline, it takes about $3 an hour to operate, right? And if you can do it that way, then you can do a lot of experiments. And the risk of failure is very, very low. And we see that very often. For example, Yelp, they run 250 experiments every week. And if they fail, then nothing happens. But if they're successful, they become part of their service or their product, right? And that is the best way, I think, to encourage people to do more big data experiments in the cloud.
Hello, everybody. Thank you for being here, and thank you for our panelists to invite me here. My name is Anup Dawar. I'm VP of Products at MapR Technologies. We were founded 7 years ago. We are a big data distribution, the only converged big data platform that allows you to do files, tables, streams, and all sorts of batch, as well as real-time analytical and operational processing on a single platform. We were also one of the fortunate ones to be early in Amazon's EMR as a EMR distribution, and that helped us to get into the cloud and learn with our customers the journey they're going through, starting from I want to just analyze some things and experiment, to now things are getting real, to connecting your operational workloads with real-time, with analytical applications. So I hope to share some of those use cases. And if there are 3 words you want to remember from my contribution here, it's global cloud processing. And I'll talk to you about what that means, because having a cloud is great. Having a platform that allows you to do global scale cloud processing is what gives you the value at the end of it. Thank you.
Global cloud processing, that sounds like El Nino. Okay. So what I would like to do is to kind of like take a few topics and have one panelist kind of lead off with it, and then have others please, you have the mics, you can grab them, but don't fight. So I would like to have the first discussion with Debanjan leading off. We just listened to Diane Green talking about how Google is thinking about really almost analytics and big data being a differentiator of how, and machine learning and all of those things for their cloud initiatives. So one of the things, and you also mentioned something along those lines in terms of the ability to run experiments quickly. So it was very interesting. So I just wanted you to comment on, do you think that people are still experimenting on the cloud, or is there kind of like going to be a full-blown commercialization of analytics-oriented businesses on the cloud? It's going to become the differentiator that Diane is talking about? What's kind of like where we are and where we are going in the relatively soon time frame?
Okay. So good question. And I'm going to use some examples from AWS. I'm not trying to promote any particular service. It's just that I know more about that than other cloud services. It is clearly experimentation is necessary in order to commercialize. And more you can experiment, better or quicker you can commercialize, right? Just to give you some data point, every day in AWS, we add enough computing capacity, which is enough to support Amazon.com global enterprise when it was a $7 billion business, right? So clearly there are a lot of people who are using it and it's growing very fast. And within AWS itself, big data is the fastest growing segment. And if you look at various different services that you run, Aurora, which is the service that I run, is the fastest growing service in the history of AWS. The second fastest is Redshift, which is also our data warehouse, the big data service. Then you have services like DynamoDB, Kinesis, and of course, S3, where everybody stores their data before or after they analyze it. And we have trillions of objects in S3, and you very often get millions of requests per second that we handle. And this space is accelerating pretty much every day, every week, right? So clearly big data is driving growth in cloud. And if you ask me that what are the different ways of kind of accelerate that growth, there are a few things that I want to talk about. One, of course, is making things very simple and easy to set up, tear down, and run, right? And which is what we do with multitude of services that we provide, as well as a lot of our partners provide. For example, we have 75 plus services that we run in AWS, and there are 2,000 plus software providers who have their software on our marketplace, and people can put them together. So it's kind of bringing retail mentality to some extent to cloud, where you can try various things out. There is not much risk if it doesn't work, and then you can fail, and there is not much penalty to that. But if it is successful, it can really, really drive a lot of growth. Couple of other things which I think we should pay attention to. One is security, privacy, and data protection, because if you are going to keep a lot of data in the cloud, it's very important people feel safe about the availability of their data and the security and privacy of it. And as Diane was saying, that we spend a lot of investment in there, and it's very difficult to do that any other way because of the scale that we have, right? And the last thing that I will mention is that how do you move data into cloud, right? That's another thing that could be an impediment if it is not handled correctly, especially when you talk about big data. And we invest a lot along with other cloud vendors. For example, we do direct connect, so people can set up direct high-speed network connection to move their data. And we recently thought that there may be other ways people want to move data, so we created a device called Snowball. This is essentially a suitcase of SSDs that we ship to people with a Fire tablet in front of it, and it has an automatic UPS level attached to it, or in the Fire tablet. So you can put your data in the Snowball device, and then after you say it's ready to go, the label automatically switches to where it needs to be shipped to our data center, right? And then you can put it in an S3 bucket, and you can get petabytes of data very, very quickly. As somebody some time back said, that UPS is still the fastest way of moving data, and it probably is.
Yeah, and I think good points, Devanjan. I think absolutely that Amazon is kind of leading the way in terms of bringing these aspects. But you touched on a couple of important points. Are security, which is the key, and that's what I mean. If you look at it, I think Diane mentioned it before. It's about 5% or 10% of the stuff is actually in the public cloud. Why isn't stuff moving there? Because people really care about their data, saying, is it secure? They're not yet feeling confident. And the second part is obviously moving the data. And more people are looking for, as you know, with the revolution of open source, Apache Foundation, and all that, people are looking for tools. And data gravity is what holds people back. The data gravity is a difficult problem to solve, because if you look at the open source solutions, There are plethora of products, but in terms of bringing those technologies together, it's a really hard job and a complex job. And that's what I think companies continue to struggle with, and that's what is, I think, going to prevent the move from, big data and analytics into the cloud, because you just don't have the right kind of tool sets that can bring things together. There are a lot of innovations going on, saying, hey, this is such a complex problem, I need to simplify it. There are a bunch of startups doing that, but nobody has solved it yet.
Yeah, the future is going to be wonderful.
Yeah.
Yes.
I mean, I'll just turn it like step back almost and say, forget the technology and always look in the context of if there is a problem to be solved, it always has to be solved in the context of what the customer will find value in, right? So I think there are two big words, big data and cloud, and I think marrying the two in a very simplistic way in some ways is doing injustice to the two. To be candid, cloud started much before big data started. I mean, cloud is not necessarily a new thing. I mean, what we are confusing is the IaaS, PaaS, and SaaS layer. SaaS started a lot of years ago. There are almost 3,000 enterprise cloud SaaS applications out there today. So that's not a new thing at all. I mean, Salesforce.com itself has been there for a long time. On the other hand, the IaaS part of the stack, which is where AWS started, obviously was all about a price arbitrage. We can scale out, we'll give you a price arbitrage, all the experiments example that you gave. And that happened in its own isolation. Big data started, obviously, where volume of data was increasing. How do we process that in a cheaper way, better way? And that's where the whole Hadoop distributions came into play. And to be candid, big data is generally disrupting, and it is disrupting because if you think about, IoT is a great use case of big data. All of the stuff around big data, and I won't get into use cases, but if you are a hospital, if you're a bank, if you want to do take Western Union. If you're a Western Union and you are in 250 countries and you basically have customer data when customers are basically remitting data, that's a real big data problem, right? Now the challenge that became, so customers started going to big data because there was value of the scale and the cost, and traditional data stores were just not able to process that, right? And without getting into technology. Where cloud comes into place as customers are getting comfortable. Take a bank, take a hospital. I am comfortable taking my physician data and moving it to the cloud, not necessarily comfortable taking my customer data and moving it to the cloud.
Very good.
So I think you have to think about what elements of workloads can go to the cloud with big data versus is big data going to go to the cloud now? As Diane mentioned, pieces of customers' value chain will go at different rate to the cloud. They went at a different rate to big data, and that's what everybody has to look at, where you can insert yourself in and create value. Whether it's a price arbitrage or a value arbitrage, at the end of the day, that's what you have to look at.
Excellent point. So I would like to put Anup on the spot for a minute here. You have been far too quiet. So I think what we are actually kind of coming very quickly upon time. So I would like to switch to a very important topic, which was a great segue that Amit opened up, which is the use cases. What kind of workloads? Right. From your vantage point, could you please kick off kind of like mentioning what kind of workloads you are seeing in public cloud versus a hybrid cloud kind of a setting?
Right.
What they know from a data gravity or security that people have commented on? What are the criteria that people are using for these use cases?
I was looking at a place to disagree with all of you, and there's not that much. So I'm just going to jump into the use cases, right? So all the problems that were shared and all the experimentation is absolutely what we see, right? We see customers that are really mature enterprise Fortune customers like biopharmaceuticals who are doing large research experiments collaboratively across geographies. And their challenge is, I want to be able to share all this data as quickly as possible with all my stakeholders in a secure way, right? And what better way to do that than if you had a cloud where everybody can access it as long as you can do it securely, right? So they come to us and say, I want to do analytics, I want to bring this data in, and it's not just about the one-time ship of the data, it's about continuous shipping of the data all the time. And it's about selecting what data you want to bring in and what you don't want to bring in, right? And so we help them out in those kinds of situations, and so solve that infrastructure problem, if you will, a plumbing problem at a larger scale. Continuous data across broad geographies coming together all the time, selectively, and being autonomously shared, right? And after that, once I have that, then I can start doing analytics on it, right? So now when I'm doing analytics on it, they want to have unified namespace, which means I should be able to, as an analytical system, access all my data. I don't want to create big data silos, right? What's happened in the industry on premise has been, oh, I have real-time event streaming, that's Kafka, store data for 7 or 8 days there. I have my operational NoSQL workloads, a la Cassandra or HBase or take your pick, right? Or document databases, and I have those in other big data silos. And then I have this big massive Hadoop where I bring in data and then do analytics, right? And they're starting to really solve this computer science problem. All of these are massive distributed systems, very sophisticated, and they are trying to struggle with that instead of the analytics. So moving to cloud, moving with a converged platform, they are able to seamlessly do this, and it's mostly in education. So that's biopharmaceuticals. Think about another example from a sharing economy, right? So I will not take the Uber example, but any other sharing economic app maybe that you want to start up, right? What do? We experiment. We take it to 3 or 4 geographies, we run our sharing experiment, we run analysis, it works. Now what do? Now your biggest thing is time to market, first mover advantage, network effect. You want to scale as fast as possible across all geographies internationally and spread it before somebody else takes it, right? If Uber's in a city first before somebody else, it's hard for the other guy to come in, right? So how do you do that? Again, your experiment has to really quickly become large. So a lot of sharing economy use cases we see start off on cloud with these premises so they can then scale out. The other thing we are seeing is, and last one, just in the interest of time, is that we don't necessarily see everything in the cloud today or everything in the premise. And I don't really want to get into that debate. But what I see is a lot of data is being generated on premise for the people who were not first in the cloud world, right? If you're a cloud first company, you started with cloud, maybe that's the case, but a large fraction of fortune, they are not in cloud. So their data continues to be generated on premise and is being brought into cloud. And new applications are generating data in the cloud and sometimes brought into on premise. So you have to create a solution that solves all these problems.
We can.
Yeah, please.
Quick thing to add. I mean, I was once giving a talk about big data in Texas, and somebody stood up and said, "Out here, son, we call it just data." And I think cloud, to some extent, has made big data not so big, right? Because there's so much of computing resources available, so much of storage available, and I think people see that, and that's why I see more and more data gravitating towards things like S3, for example.
I see. Okay. I mean,
So one
yeah,
quick
go ahead.
question, one quick thing to add. I think both of you touched on some very good examples, but I do want to bring the audience some awareness that even though we keep talking about a lot of experimentation is going on, a lot of things are being, there is some real value that big companies are actually deriving, including the government, which is actually running big data with the fast data or the latency sensitive analytics and actually doing fraud detection. In fact, you guys probably heard that IRS gets hit a lot of times with tax filings, and that actually is something that they are using big data to actually solve the fraud detection capability. Big credit card companies are using big data really to detect fraud. What they used to do, something that used to take 24, 48 hours or sometimes even months for them to detect, they are now able to run 50 to 100 analysis while you're actually charging, and they can actually detect within 5 to 10 seconds whether they should stop this transaction or not. So there's some real world good examples actually going on today.
So I would like to have Amit also comment on this, because in your position you also run into a lot of customers and their business issues.
Yeah, I mean, I think we started talking about it. I mean, those are all the right examples. I mean, I can give you 3 different industries altogether, right? I mean, let's begin with financial services. I mean, obviously data is never an issue for them. They have a lot of data. They want to process a lot of data. And in the context of cloud, it's, I mean, the number of conversations I'm having with with financial services companies that want to actually do a lot of big data, take a lot of data and process it in the cloud is growing fundamentally. And now what they're trying to do is basically take a lot of data, can you normalize it, take away any of the sensitivity in this, and can I pump it into the cloud where, to I think Debanjan's point, you have architectures that allow you to just, not spend a lot of money, you can scale out, scale up, use it up and down, it's happening. On the other examples, I talked about hospitals, right? I mean, just think about the amount of data that comes from you go to a typical hospital, right? The sensors generating the data. The physicians are walking around, they're basically tracking data now in these hospitals. The nurses basically are tracking a lot of data at the real time. What a lot of our customers are trying to do, can we bring all that data and can we make our doctors more productive, right? Because if you go, one of the biggest problems you have in a hospital is the wait time with the doctor. Now, what does a nurse do before you meet the doctor? The nurse is basically trying to do everything to make sure when the doctor comes, he is truly consulting you for the relevant problem you're there for. But if all of that available material is even available to the nurse before you arrive to the nurse can be more productive, and hence the doctor can be more productive. So the more data around each relevant patient they can get, all the history they have, all the latest contextual information they have, which is a big data problem, they can be a lot more productive. Take Food and Drug Administration. Everybody relies on the FDA label, right? I mean, if you don't see an FDA label, you probably won't buy the produce. For FDA to regulate, it's a big data problem for them. Today, what they do, leveraging, I mean, obviously, they're a customer of ours, is they track a facility, they track a drug, they track the compound, they track the individual things that go in it. They also track the trucks that go out of each individual facility to make sure they have a full view of that. So just in case they have to do any recall, they can be specific about which factory to stop or which shipment to look at or which particular drug or compound that went wrong. Those are the kind of real world problems that obviously leveraging more and more data, and you can keep it on premise, which a lot of them do. And if you can obviously desensitize it, just leverage better, cheaper processing, you absolutely will want to take it to the cloud, and customers are taking it to the cloud.
Excellent.
So I think we are kind of running out of time to discuss everything that we wanted to discuss. We can be here for probably 3 hours. These guys are so good at bringing out these nuances. So I would like to try and get some audience participation here. So does anybody have any questions for the panel here? So please, mics are there. I think Tushar is coming to shut us down.
Let me ask the question in a different way, which I asked in the session before. So cloud-based big data analytics, what's your perspective? How do you think that would affect the battle in the public cloud? How critical you think this would become in determining who wins the public cloud race?
Yeah. Maybe I can give a quick 30-second on this, right? So one thing that we didn't bring up is deep learning at all, right? I used to be an artificial intelligence neural network teaching assistant way back when, and we couldn't find an application. And now, what makes deep learning work is big data and big compute. And where do you get big data? If you can push it into a cloud-based system globally. Where do you get big compute? Cloud, right? So it's going to be a massive driver for cloud and big data, in my opinion.
Well, as I mentioned before, this is clearly the fastest growing area in cloud, at least from my vantage point, and it's growing really, really fast. And one thing, just following up on what Amit was saying, one thing we are doing very aggressively is to have different types of compliance supported in a cloud environment. So if you are in medical environment with big data, you need HIPAA and BAA compliance. If you are in public sector, you need FedRAMP compliance. If you are in financial services sector, you need PCI compliance. And once we have those compliance in place, which we have actually in AWS, people, whatever innovation they might have in terms of moving to cloud, that goes away. And we are seeing that more and more and more and more people are coming to cloud.
Excellent. Another question?
Yes, please. So TiEcon has 3 themes, cloud, data that you guys touched on, IoT. So what do you think about how IoT and devices will make that big data problem in cloud more cloudier or bigger?
I think Makran may be in a good position to address this.
Sure. So I think there are 2 aspects to it. When you talk about IoT and at Pivotal, in fact, we were looking at some of that with GE, because GE pretty much wanted to use the Pivotal software. In fact, the Predix software, which is designed for IoT, is based on the technology which we are building. There are 2 aspects to looking at it. IoT has lots of data. which comes in from the devices, but it's very much a homogeneous data set in the sense that it's the same data set, it's the event stream that you're trying to process in terms of what's coming in. And the second aspect is there is some level of edge computing that goes on the IoT devices and IoT data that is coming in, and then there is some knowledge that you have to gather based on what the Internet of Things are sending together. So the revolution that is going on in terms of analytics and stream processing, and I think now it's raining stream processing in the cloud, right? I mean, it's like, Spark streaming, there is Flink, there is, projects after project. Samza is another one. So you'll see a lot of innovations trying to come together to say, how can I process this incoming rate of information at such a fast rate? And that's what I think will lead to that IoT solution, so to speak.
Thanks. So next one.
So Michael Stonebreaker gave a talk this morning talking about Hadoop is dead. What do you think?
Well, I think that should be a question for Mapper.
Right. So, look, I think what was Hadoop? It was MapReduce and HDFS, right? And like I said, people have moved on from just doing batch analytics. It's not that people aren't doing it. They're doing it, absolutely, but they're using new technologies like Spark for computing. Hadoop as a term is starting to lose that meaning. That's why we say as ourselves, we are a converged data platform vendor, right? Hadoop is one piece, Spark, databases, streams, and IoT, big data, cloud, they all sort of have a virtuous circle. They all feed on each other. And Hadoop is just one piece of it.
Yeah, please.
Without doubt, and with full respect to Mr. Stonebreaker, he's, by the way, a legend in the space of databases. Nothing is dead. Is the mainframe dead? Let me just ask for a minute. I mean, having lived through, as technologists, it's very easy to look for the next, as a research individual, you are going to look for the next 20 years. We talk about big data here as if big data has completely, big data itself is so darn small. I mean, go look at Hortonworks, last 10K and 10Q, how much revenue do they have? It's a great company, but it's not a big enough, it has not taken over the database market yet. And I hate to say it because I unlike AWS or a Mapr, we are in the middle where we see everybody. I see Cloudera, I see Mapr, I see Hortonworks, I see AWS, I see Azure, I see Pivotal, so I see everybody. It's so small. So big data hasn't taken over anything, for crying out loud, before it can die. So I'll just put it with a grain of salt to say yes, and it's so small compared to the classic database market. In fact, the Hadoop stack itself, if you truly compare Oracle database, with full respect to them, it's not a fully hardened database stack even yet. There's a lot to be done there. And all of these science projects we're talking about, by the way, we use Spark streaming too, they're darn new. So it's barely taken over before it dies.
Yeah, I think we can probably take after Bill Clinton and ask, what is Hadoop and what is dead? Define. So I think any other questions from the audience? If not, I think since we have not been disbanded, I will just go ahead and ask another quick question. So
You are being disbanded.
Oh, I'm sorry. We are being disbanded. So I was trying to sneak something in, but Tushar was too smart for me. So the panel is available for additional questions. Please, as they get down the podium here, please buttonhole them for all your additional questions. Thank you very much. Thanks for the fantastic viewpoints and the anecdotes. Awesome. Thank you.
Good stuff.